Hello, grade 10 students. This time we will be talking about problem solving involving sequences. A lesson for Math 10. You already know about arithmetic sequences and geometric sequences and their terms. Now, we will apply the formulas and procedures we learned in solving word problems as well as modeling many real-life situations. Okay, let's have this first problem. Cinema 2 has 25 seats on the first row and has 30 rows in all. Each successive row contains one additional seat. How many seats are there in Cinema 2? Okay, as you notice on the first row, there are 25 seats. And in our problem, it is stated that each successive row contains one additional seat. So therefore, on the second row, there will be 26 sets. On the third row, there will be 27. So these terms here represent terms of an arithmetic sequence. Since this is an arithmetic sequence, so our first term here is 25. Our common difference is 1. And we are asked to find how many seats are in Cinema 2. So we are going to add or get the total number of seats from the first row up to the 30th row of that particular Cinema 2. So therefore, for this problem, we are looking for the sum of the 30 rows. Okay? So since we're talking about sum here, so we will be applying the formula for the sum of the terms of an arithmetic sequence. So this one. Okay. We don't know the number of seats on the 30th row. Therefore, we will be applying this longer formula. If you still remember, there are two formulas for arithmetic series. Since we don't know the last term or the number of seats on the 30th row, so we will be applying this formula, the longer one. So we have this sum of n terms is equal to, okay, we have n, the number of terms, divided by 2. Okay, multiplied by twice the first term plus quantity n minus 1 times d. And our n here is 30. Okay, there are 30 rows that we are talking about for this problem. So we have here s sub 30 is equal to our n is 30 divided by 2. Okay, so this one here, this 2, copy this one. And our first term is 25. Okay, plus our n here is 30 minus 1 and our common difference is 1. Okay, here we simply substitute the given informations in our problem. Okay, simplifying, we have this one. Okay, we will simplify first from the innermost. So this will be 30 minus 1, this is 29, times 1, 29. This part here, 2 times 25, this is 50. So 50 plus 29, and that is 79. And this 15 here is coming from 30 divided by 2. Okay, so multiplying these two values here, we come up with 1,185. So therefore, we can say that our seats, or there are 1,185 seats in all in Cinema 2. Okay, so here, we don't need to add 25, 26, 27 up to the 30th term. But we simply apply this formula to come up with the sum or the total number of seats in Cinema 2. Okay, so this is for the first problem. How about second problem? Okay, let's have number 2. Okay, this one. Students saved 5 pesos on the first day of the month and double his savings each day thereafter. Take note, each day thereafter, he doubled his savings. How much did he save on the 10th day of the month? Another, what is his total savings for the 10 days? Okay, so here we are asked to find out two values. First is his savings on the 10th day. And the second is we are going to look for the total savings for 10 days. So we are looking for two things here for this problem. Okay, based on our problem, on the first day, the student saved 5 pesos. And take note, he doubled his savings. So therefore, on the second day, it becomes 10. He saves 10. It's because you are going to double 5 and it will become 10. On the third day, he doubled this 10 here. So this becomes 20. So our terms for this particular sequence here are 5, 10, 20, and so on. And these terms represent what kind of sequence? This is a geometric sequence. Okay, since this is a geometric sequence, our first term here is, okay, it's 5. And our common ratio, okay, since it's geometric, so we're talking about common ratio, and that is 2. How did we get 2? That is 10 divided by 5, that's 2. 20 divided by 10, that's also 2. Okay. Next, the first thing that we are going to look for is his savings on the 10th day. So therefore, we are going to look for the A sub 10, okay, or the 10th term. Another is we are going to look for the total savings for 10 days. So therefore, we are going to look for the S sub 10, or the geometric series, or the sum of the terms, or the sum of his savings for 10 days. So that's why we have our S sub 10. So we're going to look for two things here. Okay, so okay, we have this one. This is our sequence. We have geometric sequence 5, 10, 20. First term is 5. Common ratio is 2. And we're going to look for these two things. Now, we will look for the 10th term first, the A sub 10. Since it's geometric sequence, so we will be using this nth formula, or the nth term of geometric sequence, which is A sub 10 is equal to the first term times the common ratio raised to the power of n minus 1. Substituting the given informations, our n here is 10. Since we are talking about 10th day, or yes, it's the 10th term. It's A sub 10. Is equal to, our first term is 5. And then our common ratio here is 2. Okay, and then our n again, that's 10 minus 1. So 10 minus 1, and that is 9. It's 10 minus 1, that is 9. And then you are going to raise 2 to the power of 9. Okay, that's why we have 512. So this part here, this is 10 minus 1, that's 9. Then 2 to the power of 9, or 2 raised to the power of 9, that is 512. So here you are going to multiply 2 9 times by itself. Okay, so we have 512 times 5. We come up with 2,560. So therefore, we can say that his savings on the 10th day is 2,560 pesos. Okay, this is his savings on the 10th day. Now, looking for the total savings for 10 days. Okay, so we will be using this one, the sum of his savings for 10 days. So we will be using this formula, the geometric series, or the sum of the terms of a finite geometric sequence. So this one will be our formula to be applied for this problem. Next, we have our n is 10. Since we are talking about 10 days, so we will substitute n with 10. Is equal to, our first term here is 5. Okay? And our common ratio here is 2. N, that's the number of terms. It's 10 minus 1. Okay, divided by, we have our r is 2. This one, minus 1. Okay, simplifying this expression here. So we come up with 2 exponent 10. That is 1,024. Okay, we have our minus 1, then times 5. Okay, so we come up with this value. That is 1,024 minus 1. This is 1,023. Times 5. This is 5,115. Divided by 1. Same thing. So we have the total savings for 10 days. Okay, is equal to 5,115 pesos. Okay, so again, this is the saving for the 10th day, and this one is this total savings for 10 days. It's 5,115. Okay, next we'll have problem number 3. Julie saved 10 pesos on the first day of the year, 13 pesos on the second day, 16 pesos on the third day, and so on, up to the end of the year. Following the same pattern, how much did he save on the 365th day? Okay, and how much is your total savings for 365 days? Okay, first is we are going to find out what kind of sequence we are talking about here. Okay, on the first day, he saved 13 pesos. We have 10 pesos. So therefore, our first term is 10. And on the second day, okay, he saved 13 pesos. So our second term is 13. And on the third day, it's 16 pesos. Okay, so looking to this pattern, What do you think is the kind of sequence we are talking here? And that is an arithmetic sequence. We have 10, 13, 16. It's an arithmetic sequence since we add 3 from each term to get the next term. So our common difference there is, okay, 3. Our first term is 10, this one. Our common difference is 3. And we are looking for two things here. His savings on the 365th day. Okay, so we have the A sub 365. Another is, okay, again, another is we have, okay, his total savings for 365 days. So we are going to look for two things here. Okay, so going back, we have, okay, this is our arithmetic sequence, the 10, 13, and 16. Okay, our first term is 10, our common difference is 3, and first is we are going to look for his savings on the 365th day. Another is we are going to look for his total savings for 365 days. Okay, so first is we are going to look for this one. So we will be applying the nth term of an arithmetic sequence since we are looking for the 365th term. Okay, so we have this formula. The nth term of an arithmetic sequence, this is a sub n, is equal to the first term plus quantity n minus 1 times d. Okay, so our n here is 365. Okay, since we're talking about 365th day, it's 365. Our first term is 10 plus our n is 365 minus 1, then our common difference is 3. Okay, so we have this one. 365 minus 1, it's 364 times 3, and it's 1092 plus 10, this one. So we come up with 1102. So therefore we can say that his savings, her savings on the 365th day is 1102 pesos. Okay, second question. We are going to look for the total savings for 365 days. So we are going to add his savings from the first day up to the 365th day. Okay, since we are certain about the last term, which is 1102, so we will be using this shorter formula for arithmetic series. Okay, so we have our n is 365. Our n here, yes, it's 365 divided by 2. Our first term is 10. Plus our last term or the nth term, it's the 365th term. And we already know how much is this 365th savings. Okay, that's 1102. So we will simplify, we will just simply substitute this one with 1102. Okay, so that is 10 plus 1102, so we have 1112. Okay, times this one, 365 divided by 2, that's 182.5. So multiplying these two values, we come up with 202,940. So therefore, we can say that her total savings for 365 days following that pattern is equal to 202,940 pesos. Okay, so this is for the third problem. How about for the fourth problem? Okay, we have problem number 4. During an initial phase of an outbreak of measles, the number of infections can grow geometrically. If there were 4, 8, 16 on the first 3 days of an outbreak of measles, how many will be infected on the 6th day? Okay, looking to this pattern, this one, 4, 8, 16, what kind of sequence we're talking here? This is in a geometric sequence. Of course, it's our first term is 4. And our common ratio is 2. Look at this. We multiplied 2 to each term to get the next term. So 4 times 2, that's 8. 8 times 2, that's 16, and so on. Or simply, to get for the common ratio, that is 8 divided by 4, that's 2. 16 divided by 8, that's also 2. Okay. So common ratio is 2. And we are going to look for the number of individuals to be infected on the 6th day. So we will be looking for the A sub 6 or the 6th term. Okay, so using the nth term of a geometric sequence, we have this formula. A sub n is equal to first term times r raised to the power of n minus 1. So our n here is 6, since we're talking about on the 6th day. And our first term is 4. Our common ratio is 2. Our n is 6 minus 1. So simplifying, we have here 6 minus 1, it's 5. And 2 exponent 5, this one multiplying 2 5 times by itself, so it's 32. Times 4, so we come up with 128. So therefore, we can say that 128 individuals will be infected on the 6th day, following this pattern. Okay? Now let's have problem number 5. Okay. A housekeeper receives a salary of 60,000 pesos a year with a contract of 500 pesos annual increase for 7 years. What is her total income for 7 years? Okay. So this one. First year, or our first term here is 60,000. Okay, since on the first year, her salary is 60,000. Next is, we have common difference here, which is 500. Why is it common difference? Since it is stated here that there will be an annual increase. Okay, so each year, her salary will be added by 500 up to the 7th year. Now, what we are looking here, that is her total income for 7 years. So we are going to add or get the sum of her income from first year up to the 7th year. Okay, so you don't need to add those things, but simply applying this formula, okay, the formula for getting the sum of the terms of an arithmetic sequence. So this one. We will be using this longer formula since we don't know the exact amount of the 7th term. Okay, so we will be using this longer formula. Okay, n here is 7. So we substitute n by 7. Then our first term is 60,000. Plus our n here is 7 minus 1. Then our common difference is 500. Okay, this is the value that we will be added to each year. Okay, so simplifying, we have this one. 7 minus 1, this is 6. Times 500, this is 3,000. And then this part here, 2 times 60,000, this is 120,000. So 120,000 plus 3,000 here, so we come up with 123,000. Times 3.5, where did we get 3.5? That is 7 divided by 2. Okay, so multiplying these two values, we come up with 430,500. So therefore, we can say that her total income for 7 years is equal to 430,500 pesos. Okay, so here you don't need to add her salary from the first year, second year, up to the 7th year. So we would simply use this formula to come up with the total income, her total income for 7 years. Okay, that's for problem number 5. Now, how about problem number 6? Okay. A piece of spoiled meat has some bacteria in it. The number of bacteria increases 5 times every hour. If the number of bacteria is 1,000 on the first hour, what is the total number of bacteria at the end of 5 hours? Okay, what do you think is the kind of sequence we're talking here? Take note, every hour, the number of bacteria increases 5 times. Okay, so it's 5 times every hour. So if our first term is 1,000, or if the first hour we have 1,000 bacteria, on the second hour it will become 5,000, since every hour it will be increases by 5 times. So our first term here is 1,000, our common ratio is 5. And we are going to look for the a sub 5, or the 5th term, or the number of bacteria after 5 hours. So we will be looking for the a sub 5. Since this is a geometric sequence, we will be applying this nth term of geometric sequence here. Okay, our n is 5. First term is 1,000, common ratio is 5, and here is 5. So 5 minus 1, that is 4. Then 5 exponent 4. So you are going to multiply 5 4 times. So that is 625 times 1,000. So we come up with 625,000. So therefore, we can say that there will be 625,000 bacteria at the end of 5 hours. Okay? Okay. Now, let's have problem number 7. Okay, we have a contract specifies that Marlin will receive a 5% pay increase each year for the next 30 years. So every year there will be a 5% increase, okay, of her salary. She is paid 120,000 the first year. What is her total salary over a 30-year period? Okay, take note. First year over employment, she received or she is paid by 120,000. Then each year, this will be increased by 5%. Next is we are going to look for her total salary. The total salary she received over a 30-year period. Okay, so we have, first is we are going to look for the first term or the first year, that's 120,000. Since it is stated that there will be an increase 5% each year, so for the second year, her salary will be 126,000. Why is it so? So we have 120,000 plus this one, 120,000 times 0.05. Since it is stated that there will be a 5% increase. So you are going to get the 5% of 120,000. Okay? And then you will add this to her salary in the first year. So we come up with 126,000. So this will be her salary for the second year. And for the third year, we have this 126,000 plus the 5% of this. So 126,000 times 0.05. Okay? So the value of this one added by 126,000. So we come up with 132,300. So this will be her salary for the third year. So in other words, this is our first term, our second term, and our third term. Okay, if we are going to divide third by second and second by first, we come up with a certain or common ratio, and that is 1.05. Here, 132,300 divided by 126,000, that's 1.05. Or 126,000 divided by 120,000, that's also 1.05. Since we have common ratio, these particular terms here represent terms of a geometric sequence. So we will be solving this particular problem using the geometric series or the formula in getting the sum of the finite terms of geometric sequence. So we have first term is 120,000 and we will be looking for the S sub 30 or her total salary over 30-year period. Okay, so the solution will be, okay, we have this one. The formula for the sum of the terms of a finite geometric sequence. Okay, so our n is 30. This one is equal to our first term is 120,000. Then our common ratio is 1.05. Our n here is 30. This one, since we are talking about 30 years. Minus 1 divided by our r is 1.05 minus 1. Okay, simplifying, we come up with this. 1.05 raised to the power of 30, so we come up with this value. Okay, this one. Okay, minus 1. Okay, and then 1.05 minus 1, this is 0.05. So simplifying, we have this part here. Okay, this will be 3.32199942375 times 120,000 divided by 0.05. So we come up with this value, 7,972,661 pesos and 70 centavos. So this will be your total salary for 30-year period. And that is again 7,972,661 pesos and 70 centavos. Okay, so this is how to get her total salary over a 30-year period. Okay, last problem, we have problem number 8. A car depreciates in value at a rate of 6% every year. If a car costs 850,000 pesos now, what is its value in the 5th year? Okay, previously, on problem number 7, we're talking about here an increase of 5%. So that is why we keep on adding 5% of that particular amount. This time, we're talking about depreciates. So what do you think will happen? Of course, we are going to subtract. Okay. On the first year, the value or the cost of the car is 850,000. Now, every year, the value will depreciate at 6%. So this will be, on the second year, this will be 850,000 minus 6% of this. And that is 850,000 times 0.06. Okay, so the value of this, subtracted from 850,000, we come up with 799,000. So if on the first year we have a total of 850,000, the cost of the car, on the second year it will become 799,000. How about on the third year? Okay, this value here on the second year, this one, 799,000, get the 6% of this. Okay, so that is 799,000 times 0.06. And then the value of this one, subtract it from 799. So we come up with 751,060. So this will be the cost of the car after 3 years. Okay. So this will be our first term, 850,000. Second term, 799,000. And third term, it's 751,060. Okay, so these particular terms represent a geometric sequence. Okay, so this is our first term. Why is it geometric sequence? Since if you are going to divide this term or this value by this value, we come up with 0.94. And divide 799,000 by 850,000, we come up with 0.94 still. So therefore, our common ratio is 0.94. Okay, and we are going to look for, and our n here is 5. Okay, what is the value on the fifth year? Okay, fifth year. So our n here is 5. If solution for this one is, we will be using this formula, n term of geometric sequence. Since we are asked to find out the value or the cost of the car on the fifth year, so it's the a sub 5. Okay, here it's the a sub 5 that we are looking for, or the fifth term, is equal to, our first term is 850,000 times the common ratio is 0.94. Our n here is 5 minus 1. Okay, we come up with 5 minus 1, that is 4. Next, 0.94 raised to the power of 4, or multiplying 0.94 4 times, 8 times 850,000. So we come up with this value. So again, this part here, raised to the power of 4, the value of this one times 850,000. So we come up with this value. That is 663,636 pesos and 62 centavos. So therefore, we can say that the value of the car on the fifth year is 663,636 pesos and 62 centavos. Okay? Okay, thank you for watching. I hope you learned something from this. Please don't forget to subscribe Wen's Math Tutorial. This is Teacher Con.